Hey everyone, so in this clip we're going to be talking about how we can come up with a way to add all the terms in an arithmetic sequence. Okay, so what do I mean by this? Well, this would be a sequence just like if you have a geometric sequence, except this time instead of multiplying by a common ratio for each term, we're actually going to be adding the same amount to each term that comes next in the sequence. So the sequence itself can be described by a plus d, a plus 2d, all the way up to however far that you want to go, all the way up to your last term that you want to do. And okay, so our first term is a, goes to L. The difference d we're going to define as the difference between any nth term and the term that immediately precedes it. So we're going to be able to define that very soon here. Okay, so if we wish to describe any nth term here, then we can just say that this is a plus some d times n minus 1, because we remember we have to offset it by 1 because the first term a does not have an extra difference piece applied to it. But also if we just multiply this out, it can also be represented as a plus dn minus d. So once again, the difference d we're going to define as the difference between any nth term and the n minus 1 term. So using this to describe any general nth term that we have, let's take the difference, and that's what we're going to define this by. So for our nth term, we have a plus dn minus d, and we're going to subtract the n minus 1 term from this. So a plus d, and put this in parentheses, minus a plus d, and we're going to put n minus 1 in here, so n minus 1 like this. So this equals a plus dn minus d minus quantity a plus, and notice how n minus 1 is just n minus 2, so let's write that in there like this, equals a plus d n minus d, and then we're gonna multiply this out, so minus a plus dn minus 2d, and now what do we have? A plus dn minus d, multiply the minus 1 out, we get minus a plus dn plus 2d, and notice how the a minus a go away, and the that should be a positive, okay, because we're supposed to have the positive dn and the minus dn go away, and what are we left with? Minus d plus 2d equals d, because that's once again how the difference is defined. Okay, so we want to come up with a way to figure out what Sn is for any amount of terms. So call our summation S sub n for n terms. equals the limit as n approaches an infinite amount of the summation of x equals 1 to the n, or to n, and we're going to put this in here of a plus d times x minus 1, which can also be rewritten as limit as n approaches infinity of summation maximum is 1 to n of a plus dx minus d. Okay, so now we have to come up with a trick to figure out what this is. So let's write out what we're doing here. So Sn equals a plus d plus a plus 2d plus continuing down. The last couple terms are going to be L minus D, and then plus L for the last term, let's say. And now the trick here is we can actually put this in the reverse order. So let's go ahead and do that. L plus L minus D plus continuing down to A plus 2D plus A plus D plus A. And we're just going to straight up add these. So notice how Sn, we have 2 Sn, and notice how when you line up the terms perfectly here, we're just going to get A plus L. And notice how the plus D and the minus D, or the plus 2D and minus 2D, are going to go away, and all of this. So the minus D and the plus D go away here. You're left with an L and an A over there. So basically, we're just going to have A plus L plus A plus L plus A plus L, and we're going to have that n times basically. So now if we just take half of what this is in order to get just Sn alone, so divide the whole thing by 2, then we're going to come up with the fact that this is just A plus L divided by 2, but remember we want to do it for n terms, so times n, and this is more commonly seen in textbooks in the form n over 2 times A plus L for n terms. And notice here that this is very useful for when n is not infinite, because notice that if we take the limit as n approaches some infinite amount of n over 2 times A plus L, then that's just going to run away to the positive infinity, because we're going to have an infinity over 2 times A plus L. So basically this one does not actually converge. So this is more useful for finite n. Okay, so this is how to derive the formula to add in the arithmetic series, and hopefully you found that helpful, and you come back and watch the next one where Joe shows you how.